Hey everybody, this is Larry. This is day 30th? No, 29 of the Leetcode Day Challenge, and there's a weekly premium video that I'll probably do. So hit the like button, hit the subscribe button, join me on Discord if I could find this button to reset the code, and let me know what you think about today's problem. Today's problem is 2483, minimum penalty for a shop. So you're given a customer visit log of a shop represented by 0 index string, customers consisting of only characters N and Y. Okay. What does that mean? So that means that a customer came that day, or customers came that day, where N is no customers came that day. Okay. So for every hour when the shop is open and no customer come, the penalty is increased by 1. For every hour when the shop is closed and customer come, the penalty increases by 1. I don't know why they won't increase by 1. Just say it's a score of 1, right? Like, I don't know. Then you just sum up the penalty, right? Anyway, return the earliest hour in which the shop must be closed to incur minimum penalty. Okay, so it seems like the idea, I feel like we've done this problem on the Leetcode contest maybe a couple of times the last year, maybe 2-3 times. Not quite the exact same phrasing, but the same idea, right? The same idea is that basically now, so you're giving some string. I'm just banging on the keyboard here, it's just random. And then now, basically, you're trying to close, so your schedule is going to look something like this for some divider in the middle. And basically, if you essentially you get a penalty if it's closed, which is the top, and customers came, so maybe this is a customer coming. Oh no, shop's open, sorry, shop's open, and this is customer is coming. So if customer comes here and shops is closed, then you get a -1 or +1 penalty. Or if there's no customer here and the shops is open, you have Y. So yeah, basically this. And another way to phrase it, of course, now is just another way to phrase it, of course, is just given, you have to find the prefix of Y and suffix of N such that you have the minimal difference, right? And of course, this problem can be solved with sweep line algorithm, maybe it's just, it is sweep line, but you can also visualize it a little bit differently. But basically, yeah, in a way it is brute force, right? So you can think about it as, okay, first we start with all ends, so the shop is not open, and then maybe next let's test it for this, 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 and so forth, right? Of course, if you do it naively, n, not going to be confused with this n, and it's going to be 10 to the 5th, which is 100,000, and 100,000 squares is not going to be enough. So the idea still is that you do a brute force version of this, but in a way that lets you build off what you already know, right? So that's basically the idea, and yeah, let's get to it. So Y is equal to customers dot count of Y, and N is equal to length of customers. So then nose is equal to customers dot count dot, or we can also just write this as N minus. So you could do one fewer pass, if you will, right? And then now we just look through the index, right? And now we start with so best is equal to 0. The current count, maybe I was going to write current, is equal to the number of Y's, because basically this is our current state with all no's, and all Y's are going to be penalty. So we have Y's, right? So, and we'll just set that as the current best score, right? So we just don't open. This is what happens. Here we convert the ith element to Y. So then now what does that mean? That means that if customer sub I is equal to Y, then penalty goes down, right? Ooh, why didn't I have current? Whoops, I did have current, but then I'm very confused. Current goes down, right? Because now it converts this Y into a no. So then now, because it means that it converted an incorrect thing to a correct thing, right? So thing that match. And then the other case is if this is a no and you convert it to a yes, then in that case, and actually, sorry, I lied a little bit, or it's a little bit inaccurate, sorry. But yeah, after you do match 3 and then now you convert this n to a y, then what happens is that now the penalty goes up because now you're introducing one incorrectness, right? So we can do else, oops, don't know how to Python. And after that, we just see if it is this prefix is better than the best possible answer, and that's pretty much it. Unless I'm wrong, then we have to do a little bit more because of some time. Okay. It is also possible that I misunderstand this part, but of course, this problem, which would be funny. Did I mix it up? Output 5. Oh, of course we on min. Sorry. I mean that's a easy mistake to fix, though this is now wrong. Dong dong dong. Did I misunderstand this? Oh, I see. Sorry. I'm returning the wrong thing, that's why. I'm sorry, I was just looking through the examples trying to understand like why 1 is not minimal, and then I realized you're supposed to return the hour. So okay, I mean, obviously this is just, you know, minor fix. So yeah. Best index is equal to 0, or best hour is equal to 0, right? And then here, if current is less than best, then current is equal to best, and best index is equal to I+1 maybe. Yeah, maybe. The I+1 may be a little bit off, but depending on how they define it. Yeah, okay. Yeah, that's pretty much it. I think linear time, constant space. We do 3 passes or 2 passes, 1 and 2, depending how you want to count the end part. But yeah, let's give it a submit, because I think once I forgot to submit, even though I did on video. So okay, yeah, 1246 day streak, and that's all I have for this one. I think the biggest thing about Sweepline is that it seems like an intimidating algo if you haven't kind of have this practiced. The idea, and maybe when I mean, I already done it. Oh no, this is only wow, this is almost like 10 months ago now. Maybe this was the problem that I remember from the contest actually, but there was another one I think, like a couple that are very similar. But yeah, the key thing to know is that the way that we're trying to conceptualize what we want to do is kind of brute force, in that we're trying every possibility, right? So, well, brute force isn't maybe the right word for it, but we're doing an exhaustive testing everything, right? Except for that we're building on the previous state that we already know to kind of make an update in all one time instead of recalculating everything. And that's basically the core part of it. And this, I mean, obviously for this part, this is a very, relatively speaking, a simple application of this once you see the idea, of course. I mean, if you haven't seen it, it's a little bit tricky. But this is a very basic application of that idea. But this idea does come up a lot, especially on more and more complex problems. So definitely make sure you're familiar with this concept of just incremental updates, right? And in this case, each update obviously is O of 1, but once you kind of start thinking about them as sweep lines or line sweep or whatever, you can maybe, there are problems where the meat of this problem is log n, and then it becomes n log n instead, and that usually is fast enough. But yeah, that's all I have for this one. Go do the premium problem afterwards, so jump, and I'm going to jump to it. You could join me, and we can jump and join and jump. I don't know what I'm saying anymore. That's all I have for today. Have a great rest of the week, everybody. Stay good, stay healthy, to good mental health. I'll see y'all later, and take care. Bye-bye.